Hello everyone and welcome to Python tutorial part 3! In this session we're diving deeper into Python programming by exploring functions, understanding dictionaries, and learning essential error handling techniques. By the end of this part you'll be equipped to write more organized, reusable, and robust Python code. Cover how to define and use your own functions to make your code more efficient, how to store and access data using dictionaries, which are powerful key-value data structures, and how to gracefully handle unexpected situations that might cause your program to crash. This will be a hands-on session, so let's get started right away! Let's set up our environment with some helpful comments. About our main title for this session, Python tutorial part 3, functions and errors. A comment, as you might remember from previous parts, is ignored by the Python interpreter but is incredibly useful for us, the developers, to understand the code. It's a clear heading, letting anyone quickly grasp the topic of this particular code segment. Below that, I'll add a line of dashes just to visually separate our title comment from the introductory text that follows. To make the code more readable and structured, elaborate on what we'll learn. I'll add another comment in this part. We'll learn how to reuse code. It highlights the primary benefit of functions, avoiding redundancy and promoting modularity. We write a piece of code once, give it a name, and then call that name whenever we need that logic executed. Think of it like a mini program within your main program. It's a fundamental concept in all programming languages and is crucial for building larger, more maintainable applications. Following that, I'll add a second key objective and handle unexpected situations. This refers directly to error handling. No matter how carefully we write our code, there will always be scenarios we didn't anticipate or external factors like user input or network issues that can cause problems. Learning to handle these gracefully rather than letting the program crash is a sign of mature and professional development. We want our programs to be resilient and user-friendly, even when things don't go exactly as planned. This main topic, indicated by 1. Defining a function will focus on how to create these reusable blocks of code. In Python, we define a function using the def keyword, followed by the function name parentheses for any parameters it might take, and then a colon. Let's create an example function. I'll type def calculatax price rate equals 0.1, signals the start of a function definition. Calculatax is the name of our function. It's descriptive and tells us what the function does. Inside the parentheses, we have our parameters price and rate. That rate has a default value of 0.1. This means if we call the calculatax function and only provide a price, the rate will automatically default to 0.1, which could represent a 10% tax rate. If we provide both a price and a rate, then our provided rate will override the default. A very useful feature for making functions flexible. Finally, the colon indicates that the next lines, which define the function's behavior, will be indented. Indentation is crucial in Python for defining code blocks. Inside our calculatax function, on the next line, I'll add the core logic return price rate. The line is indented by 4 spaces, showing it's part of the calculatax function's body. The return statement is how a function sends a result back to the part of the code that called it. In this case, our function will calculate the tax by multiplying the price by the rate, and then it will return that calculated tax amount. The return value can then be stored in a variable or used directly in other operations. See this function in action. First, I'll add a print statement to give some context to our output. In the terminal, print calculating tax for $100. Simply display a message before we perform the calculation. String calculating tax for $100 enclosed in double quotes will be printed as is. When we run this code, you'll see the line calculating tax for $100 appear in the output terminal. It confirms that our print statement executed. Let's actually call our calculatax function. I'll type tax equals calculatax 100. Here we're calling the calculatax function and we're passing 100 as the price. We didn't specify a rate. It will automatically use the default 0.1. The value that the function returns, which will be 100 0.1 or 10.0, will then be assigned to a new variable called tax. To verify our result, I'll add another print statement, print ftax $tax. This is an f string denoted by the f before the opening quote. These are a powerful and convenient way to embed expressions inside string literals. Something inside curly braces within an f string is evaluated and converted to its string representation. $tax will insert the value of our tax variable directly into the string. To execute this, the output will now show tax $10. This demonstrates that our calculatax function successfully ran, calculated the tax, returned the value, and we then printed it out. A simple example illustrates the power of functions. We've encapsulated a piece of logic, price rate, so we can reuse it effortlessly for different prices without rewriting the multiplication every time. Moving on to our second topic, I'll add a new comment too. Understanding dictionaries key value. Dictionaries are incredibly versatile data structures in Python, allowing you to store data in key value pairs. Lists are tuples, which are ordered collections. Dictionaries are unordered, and you access items by a unique key, not by their position. Think of a real-world dictionary where you look up a word, the key, to find its definition, the value. Create a dictionary to store user information. I'll type user equals name Ivan, level 10 XP 450. Entire dictionary is enclosed in curly braces. Item within the dictionary is a key value pair, separated by a colon, and the pairs themselves are separated by commas. Name is a key and Ivan is its corresponding value. Level is a key with value 10 and XP is a key with value 450. Are typically strings, but they can be any immutable type like numbers or tuples. It can be of any data type, including other dictionaries or lists. dictionaries extremely flexible for representing complex data. See how to access specific pieces of information from our user dictionary. Type another print statement using an f-string printf user level user. Access a value in a dictionary. You use the dictionary variable name followed by square brackets containing the key. User will retrieve the value associated with the key name, which is Ivan, and user will retrieve the value 10. Running this line, the output in the terminal will be user Ivan level 10. Clearly shows how we can easily extract specific data points from our structured dictionary using their respective keys. Is much more intuitive than remembering an index, especially when dealing with many different types of data about a single entity. Let's explore how to modify data within our dictionary. Section is 3, updating the dictionary. Dictionaries are mutable, meaning we can change their contents after they've been created. Update Ivan's experience points. Currently XP is 450. I'll type user plus equals 50. This line accesses the value associated with the key XP in the user dictionary, which is 450, adds 50 to it, and then updates the value for that key to the new total. This plus equals operator is a shorthand for user equals user plus 50. Ivan's XP will increase by 50. To confirm the update, I'll add a print statement printf updated XP user. Display the new value of the XP key from our user dictionary. Upon execution, you'll see updated XP 500 in the output terminal. This confirms that we successfully updated the value associated with the XP key. Its ability to easily add, remove, and modify key value pairs makes dictionaries incredibly powerful for managing dynamic data like game player stats, configuration settings, or records in a database. We'll move to a crucial aspect of writing robust code error handling. Section is 4, error handling the try/except block. When your program encounters an unexpected situation, like trying to divide by 0, accessing a file that doesn't exist, or converting an invalid input into a number, it raises an exception or error. If these exceptions aren't handled, the program will crash and terminate. Try/except block allows us to try running a piece of code and catch any specific errors that might occur, so we can handle them gracefully instead of crashing. Demonstrate this with a common error. Start by typing try. The code indented underneath this try statement is the block that Python will attempt to execute. If an error occurs within this block, Python will stop executing the try block and jump to the corresponding except block. Inside the try block, I'll type a line that is designed to cause an error in ABC. Statement attempts to convert the string ABC into an integer. So, as you might expect, ABC is not a valid number, so Python cannot perform this conversion. The operation is guaranteed to raise a value error. Now we need to tell Python what to do if a value error occurs. Type except value error as E. The except keyword signifies that this block of code should be executed if an exception of a specific type occurs in the preceding try block. Here, value error is the type of error we're expecting when we try to convert ABC to an integer. E part is optional but very useful. It captures the specific error message generated by Python and assigns it to the variable E, allowing us to print or log it for debugging purposes. Inside our except block, I'll put a print statement printf caught an error E. This line will only execute if a value error occurs in the try block. It uses an f-string to clearly state that an error was caught, and then displays the specific error message provided by Python, which is stored in the E variable. This is a much more user-friendly way to deal with an error than letting the program abruptly stop. When we run this segment of code, you'll see the following output in the terminal caught an error invalid literal for int with base 10 ABC. That the program didn't crash. Instead, it printed our custom error message, including Python's explanation of the value error. The power of try/except it allows your program to continue running even after encountering a problematic operation, giving you the chance to log the error, inform the user, or take alternative actions. Further illustrate error potential, imagine we tried to access a key in our user dictionary that doesn't exist. Since if I typed printf status of Ivan user on a new line after our try/except block, and we didn't have a status key in our user dictionary, this line would cause a key error. This print statement is outside our current try/except value error block. It wouldn't be caught by it. This highlights that you need to anticipate different types of errors and provide appropriate except blocks for each, or use a more general except exception as E to catch any type of error, though it's generally better to catch specific errors when you can to apply appropriate handling. Summary, today we've covered some fundamental concepts that are key to writing organized, dynamic, and robust Python applications. Started with functions, learning how to use the def keyword to create reusable blocks of code, accept parameters, and return values. This modular approach is essential for code organization and efficiency. We delved into dictionaries, a powerful data structure for storing data as key value pairs, which provides an intuitive way to manage structured information. Saw how to define them, access values, and update them. Finally, we tackled error handling with the try/except block, a critical skill for preventing your programs from crashing due to unexpected inputs or situations, allowing you to manage errors gracefully and provide a better user experience. Consistent practice is key to mastering these concepts. Experimenting with different functions, building more complex dictionaries, and simulating various errors to practice your try/except blocks. Building blocks will serve you well as you continue your Python journey. For joining Python tutorial part 3, found this session informative and engaging. If you have any questions or comments, please feel free to leave them below. Soon for Python tutorial part 4, where we will explore even more exciting aspects of Python programming. Happy coding!